Hello Warriors, this is Miss Lemons, and today we are going to be walking through the ions PowerPoint. Now, you should have your ions notes in front of you. Before we begin, I would grab definitely a pencil, maybe a different color if we want to augment our notes or add additional information in our notes. So, go ahead and grab your packet, look at your table of contents, find your ions notes, and we're going to get started. And keep in mind, too, that you are allowed to go through this PowerPoint at your own speed. I'm just going to be walking through it via video. This is optional to you. And keep in mind that while I go through this video, I'm only going to be pausing for brief moments so that I can continue through the video. Just make sure you are pausing for you to write down the information on each slide. So let's get started. Okay, so today we're going to be talking about how the atoms of the same element can be different when we're talking about the arrangement of their electrons. You should be able to explain where the charge on an ion is derived from, determine the charge of an ion based on the atom's placement on the periodic table, and write in isotopic notation and include the charge of that ion in that notation. So, I want you to take a moment to answer the following questions in your notes. What happens when we change the number of protons in an atom? What happens when we change the number of neutrons? And what do you think happens when we change the number of electrons in an atom? So pause the video, take a moment to answer those questions yourself. So of course, we want to make sure that we are crossing out and correcting if we got any of these wrong, so use that different color. But if we change the number of protons, we know that we change the element. So here we have 2 protons, that makes this helium, 2 protons, 2 neutrons, and 2 electrons. Here we have lithium, that's 3 protons, 2 neutrons, and 2 electrons. And because we added that additional proton, we are no longer helium, we are ionized lithium. That charge, ionized, we're going to be talking about today. If you change the number of neutrons, we change the isotope or the mass number or the number of neutrons. So here we have helium-4 with 2 protons, 2 neutrons, and 2 electrons. And we have helium-5. The mass number has increased because we now have 2 protons, 3 neutrons, and 2 electrons. Remember that those mass numbers, we calculate those by adding protons plus neutrons. Electrons don't really have a mass. Okay, and then what do we think happens when we change the number of electrons? Well, here we have lithium with 3 protons, 3 neutrons, and 3 electrons, so a neutral atom of lithium. And here we have removed one of those electrons. We have 3 protons, 3 neutrons, and 2 electrons. So now we have this positively charged, this ionized lithium. So, an ion. It's an atom or a group, a cluster of atoms that has a positive or negative charge because it has gained or lost electrons. A little bit of review. Remember that protons are positive, neutrons are neutral, and electrons are negative. So, if we pluck any given element off of the periodic table, we know that they're going to be naturally neutral. And this is because the number of protons, so 3 protons, is going to be equal to the number of electrons. So 3 protons, 3 positive charges, and 3 electrons, 3 negative charges. Those are going to cancel each other out. So because they cancel each other out, they have no charge, or these atoms have no charge. But what if we plucked an atom from the periodic table? What if it loses or gains electrons? Well, the atom then becomes charged, and charged atoms are called ions. So there are 2 different types of ions. There are cations, which are positively charged ion, and they are formed when an atom loses electrons. So that's kind of a hard thing for us to remember. So formed when an atom loses electrons, I would say, because it's positively charged, so that can be kind of difficult to view if it loses electrons. So instead of saying it loses, subtracts, negative, all right, loses electrons, it is losing electrons, but think of it in terms of we are losing negative charges, right? If we think of it in terms of losing or gaining negative charges, if you lose negativity, it's going to become more positive, right? So, and keep in mind that if we have more protons than we do electrons, that means we're going to have an overall positive charge, okay? Now, anions are negatively charged ions, and they are formed when an atom gains electrons. Again, this can be really confusing for students. We gain, people think, oh, gain, positive, plus, addition, right? But we're not gaining in a positive sense, we're gaining more negative charges. So again, I'm going to go ahead and add that to my notes to just help me visualize that a little bit better while we're starting off with ions here. So that means that the number of protons is less than the number of electrons in that atom. There are more negative charges than there are positive charges, which means we would have an overall negative charge. Okay, so here are 2 memory tricks for each one. 2 memory tricks for cation, 2 memory tricks for anion. And I want you to pick the one that resonates with you the most. So the first one is always going to be the sensible one, the smart one, the one that uses the letters. So if we look at the word cation, it's a positively charged ion. And that T in the center kind of looks like a plus symbol. So we can kind of say that, we can kind of say that this looks like a positive symbol. Therefore, it's positively charged, right? Okay, that's really clever, but here's how I remembered it in high school. The word cat is inside this word, cat, and who doesn't like cats, right? Cats are cute. Like, even if you're not a cat person, you can't deny that they're cute, okay? And that's such a positive thought, right? Meow. Positive cation. Ha ha. So take a moment. I would like for you to pick the atom trick that works best for you. Also cat toast. All right, anion, the memory tricks I have here. Of course, we have the witty, clever one from Mrs. DeGlopper, which uses the letters here. An anion, get this, it's a negative ion. How great is that? This is so clever. So clever. I never thought of that. Now, when I was in high school, the way I remembered it is that when you look at this word first glance, it kind of looks like the word onion, and nobody likes to have bad breath, not oniony breath. So it's kind of a negative connotation. So negative onion, right? So, so you go ahead and pick the memory trick that's going to stick best with you and add it to your notes. So, at this time, I am done going over ions with you. We are now going to go ahead and draw some examples together. This is the video that is required of you today. So you want to make sure you absolutely watch that second video of me walking through how to draw these ions and calculate their charges. In the meantime, have yourself a wonderful day.